While dueling pistols in the hands of nobles epitomized personal honor and a very close-range precision, the widespread dream of precision on the broader battlefield remained largely unfulfilled for centuries. Imagine a soldier, armed with a standard musket, whose effective accuracy rarely extended beyond 50 yards, making mass volleys the only viable tactic. For a long time, the chaos of battle often favored sheer numbers over individual marksmanship, a paradigm that seemed unbreakable in the age of smoothbore firearms. For nearly 2 centuries, the smoothbore musket dominated European battlefields, exemplified by the British Brown Bess or the French Charleville models. These weapons, while reliable for mass fire, propelled a spherical lead ball with little accuracy beyond rudimentary ranges. Their primary utility lay in delivering a wide, albeit inaccurate, volley of lead against enemy lines, relying on volume rather than pinpoint precision. The fundamental limitation was the smooth interior of the barrel. As the round ball bounced erratically down the barrel, its trajectory became unpredictable upon exit, leading to poor accuracy over distance. This inherent flaw dictated battlefield tactics, favoring dense formations and close-range engagements where individual skill mattered far less than disciplined, synchronized firepower. However, the concept of rifling, cutting helical grooves into a gun's bore, emerged much earlier, as far back as the late 15th century in Augsburg, Germany. Early German gunsmiths, primarily crafting hunting rifles, discovered these grooves imparted a spin to the projectile, stabilizing its flight like a thrown football. This spin dramatically increased accuracy and range, making hunting more efficient and predictable. Despite its demonstrated advantages in precision, rifling remained largely confined to specialized hunting weapons and target shooting for centuries. The primary deterrent for military adoption was the laborious loading process. The lead ball had to be forced down the rifled barrel to engage the grooves, a slow and difficult task that fouled the barrel quickly. This was simply impractical for the rapid reloading needed in the heat of battle. Yet, the allure of precision never faded entirely, especially for roles requiring specific targeting. Snipers, marksmen, and specialized skirmishers occasionally employed rifles, even in military contexts, for their ability to pick off high-value targets. This niche application hinted at a potential future where precision could finally overcome the challenges of battlefield utility. The first significant military adoption of a practical rifle came from the American colonies in the 18th century, born out of necessity on the frontier. German immigrant gunsmiths in Pennsylvania, adapting their European traditions, developed the Pennsylvania rifle, later famously known as the Kentucky long rifle. This weapon was a game-changer for settlers and militia. The long rifle featured an exceptionally long barrel, typically 40 to 48 inches, and a smaller bore caliber, often around .45 to .50 inches. This design, combined with a greased linen patch wrapped around a slightly undersized lead ball, allowed for easier loading than earlier rifles. The patch both sealed the bore for better gas pressure and engaged the rifling, imparting a stable spin. The extended barrel also facilitated a more complete burn of the black powder, increasing muzzle velocity and enhancing accuracy significantly. With expert hands, these rifles could reliably hit targets at ranges exceeding 200 yards, a stark contrast to the musket's effective range. This precision was invaluable in skirmishes against Native American warriors and later, during the American Revolution. During the American Revolutionary War, 1775 to 1783, American riflemen, often from frontier regions, used these long rifles to deadly effect. At the Battle of Saratoga in 1777, Daniel Morgan's Corps of Rifles played a crucial role, targeting British officers and artillerymen with devastating precision, severely disrupting their command structure. The British were shocked by the accuracy and range of these frontier weapons. The British, initially dismissive of these squirrel rifles, soon learned to respect their lethality. This newfound respect spurred the British military to reconsider its stance on precision firearms. They recognized the tactical advantage of dedicated sharpshooters, even if mass adoption of rifles for line infantry remained impractical due to the slow loading times. Driven by their experiences in America and the emerging threats of the Napoleonic Wars, the British Board of Ordnance initiated a project to develop a military rifle suitable for their army. In 1800, after trials, they adopted the pattern 1800 infantry rifle, designed by Ezekiel Baker, a master gunsmith from London. This would become known as the Baker rifle. The Baker rifle was shorter than the American long rifle, with a 30-inch barrel, but still substantial for a military weapon. It featured a .625 caliber bore with 7 rectangular grooves, a design intended to provide consistent spin and accuracy. Unlike the flintlock muskets, it utilized a sturdy sword bayonet, reflecting its role as a frontline skirmishing weapon. Crucially, the Baker rifle was issued to specialized units, most famously the 95th Rifles, distinct from the red-coated line infantry. These green jackets were light infantry, trained in skirmishing tactics, independent action, and marksmanship. Their dark green uniforms provided camouflage, a radical departure from the brightly colored uniforms of the era, signifying their specialized role. The 95th Rifles revolutionized light infantry tactics. They operated in loose formations, often ahead of the main columns, harassing enemy skirmishers, targeting officers, and providing cover for advancing or retreating forces. Their extensive training emphasized individual marksmanship and tactical awareness, making them highly effective in broken terrain and urban environments. Their prowess was proven during the Peninsular War, 1808–1814, under the Duke of Wellington. At the Battle of Vimeiro in 1808, the 95th Rifles were instrumental in repelling French advances. Riflemen like Edward Costello and Sergeant Patrick Seller became legendary for their ability to pick off French officers and NCOs at considerable distances, disrupting enemy command and morale. The Baker rifle and its dedicated riflemen demonstrated beyond doubt the military value of precision firearms, even if loading speed remained a bottleneck. It was a clear step towards recognizing the individual soldier's potential for accurate, decisive fire, moving beyond the smoothbore's reliance on massed volleys. Yet, the search for a fast-loading, accurate military rifle continued. The enduring challenge for rifled firearms was the paradox of accuracy versus speed. To achieve accuracy, the projectile needed to engage the rifling tightly, but this made loading a slow, arduous process. Military strategists desperately sought a way to combine the precision of rifling with the rapid reloading capabilities of the smoothbore musket. Several inventors attempted to solve this in the early 19th century. Henri Gustave Delvine, a French officer, developed a rifle in 1826 with a chamber smaller than the bore, allowing a round ball to be dropped in easily and then expanded into the rifling with a ramrod. Later, Louis-Étienne Thuvenin improved on this with a stem at the breech, around which the ball was hammered to expand. While these designs improved loading speed and accuracy over traditional rifles, they were still far from ideal. The process of forcing the bullet to expand was still somewhat slow, and the soft lead balls deformed easily, leading to inconsistencies. A truly revolutionary design was needed to bridge the gap between precision and practical battlefield reloading. The breakthrough arrived in the 1840s, primarily through the work of French Army Captain Claude-Étienne Minié, building upon Delvine's concepts. Minié developed a revolutionary bullet, the Minié ball, which would forever change the face of infantry warfare. It was a conical, hollow-based lead projectile, slightly smaller than the rifle's bore. The brilliance of the Minié ball lay in its ingenious design. Its undersized diameter allowed it to be easily dropped down a rifled barrel, enabling rapid muzzle loading, much like a smoothbore musket. The magic happened upon firing. The explosion of black powder behind the bullet forced its hollow base to expand outwards, engaging the rifling grooves. This expansion, known as obturation, imparted a stabilizing spin to the bullet, granting it unparalleled accuracy and range for a muzzle loader. Suddenly, a common infantry soldier could load a rifled firearm almost as quickly as a smoothbore musket, yet achieve effective accuracy at ranges up to 300 to 400 yards, a capability previously only dreamed of by specialized marksmen. The impact was immediate and widespread. Major armies across the globe swiftly adopted rifles firing the Minié ball. The British developed the pattern 1853 Enfield rifle, while the United States adopted the M1855 and later the M1861 Springfield rifle, all designed around the Minié principle. These new weapons rapidly replaced smoothbore muskets as the standard infantry armament.
The true devastation of the Minié ball was tragically demonstrated in the mid-19th century.
The Crimean War, 1853 to 1856, saw British and French forces, equipped with Minié-type rifles, inflicting horrific casualties on Russian troops still largely armed with smoothbore muskets. Later, the American Civil War, 1861 to 1865, became the deadliest conflict in American history, largely due to the widespread use of Minié ball-firing rifles. The Minié effect profoundly reshaped battlefield tactics. The massed infantry charges that had been a staple of Napoleonic warfare, once merely dangerous, became suicidal. Advancing in close formations against defenders armed with Minié rifles meant being mowed down at ranges far beyond effective musket fire. This forced a radical re-evaluation of offensive strategies. The increased lethality of the Minié ball led directly to the rise of defensive warfare, characterized by trenches, earthworks, and fortifications. Soldiers sought cover from the unprecedented accuracy of enemy fire, digging in to minimize exposure. The era of the gentleman's war, with its open field maneuvers, began to fade, replaced by a more brutal and static form of combat. Beyond tactics, the Minié ball had a devastating medical impact. Its large caliber and soft lead, combined with the high velocity imparted by rifling, created horrific wounds. Unlike the clean holes often made by musket balls, Minié balls would flatten, tumble, and fragment upon impact, shattering bones and tearing through flesh, often necessitating amputation as the only recourse for survival. From a specialized hunting tool to a weapon for elite sharpshooters, rifling, combined with the genius of the Minié ball, transformed the rifle into the primary instrument of infantry combat. It fundamentally altered the soldier's role, elevating individual marksmanship and strategic positioning over sheer numerical presence. This shift marked a profound evolution in the history of warfare, making precision accessible to every soldier. The era of rifling brought unprecedented accuracy to the battlefield, making every shot potentially deadly, but it still required a laborious reloading process for each individual round. The next great leap in firepower would come not from a single shot, but from the ability to fire multiple times without the need for manual reloading after every discharge. Join us next time as we explore the invention that put 6 shots in a soldier's hand, forever changing personal combat and frontier justice.